Bismillahirrahmanirrahim. Alright, I will recap again the CLO1 which for this course, Petroleum Geochemistry and Basin Modeling. Right, for the CLO1 course linear outcome 1, now is for explain and appreciate the jobs that are carried out by different petroleum geochemists. Alright, moving on. So why do you need to study or have a knowledge on petroleum geochemistry? Very simple. Okay, the main purpose of an oil and gas company is to find the oil and gas pool, in which the selection of the drilling of petroleum prospect has to be done by petroleum geologists. So meaning that as a petroleum geologist, we have a request to find more oil and gas. So therefore, we need to have a numerous technique to drill a petroleum prospect to find new pools of petroleum. So the techniques involved here are all those knowledge under physics, geophysics engineering, fluid mechanics, petroleum geology, physical geology, and everything that you guys can see here. So I'm really sure that you have learned all these things when you were in first year, second year, third year, and now is your final year, which I will focus more into the details knowledge on petroleum geochemistry. So what is the meaning of geochemistry as highlighted in red here? So geochemistry here means a branch of chemistry to resolve the problems occur in geology. So for petroleum geochemistry, it means here a branch of geochemistry to resolve the problems occur in petroleum geology. Moving on, as the introductions for petroleum geochemistry, historically it has started as early as in 1936, which 100 years ago, and now is further specialized into exploration, development, and production. Alright, why is petroleum geochemistry is very important? We have 4 main points here. The first one is it serves as a tool for reducing the uncertainty that occur in explorations and productions of frontier basin. You need to bear in mind that petroleum geochemistry have been used 100 years over ago to solve exploration problems that occur in exploration, productions, and development while minimizing the cost. Please, you need to make sure that while you encounter a problem, the first and foremost of the thing that you need to think about how to minimize the cost, like what happened now in oil and gas industry. Because the oil price drop, everything almost shut down because we have no budget on that. So the one that still ongoing, the first thing they have to consider is we can continue or we can still proceed all those planning, but then the first thing we need to think is about the cost. So everything is about the cost. Alright, second point here is if you are a petroleum geochemist, you will generally study on the origins of petroleum and how it moves and where it pools. So usually a petroleum geochemist, they will analyze oil, gas, sediment, rock, and water to support decisions about exploration, drilling, and production. Okay, as well as where to find oil and gas pool. Right, part of that, you need to actually imagine on knowing the kind of hydrocarbon being collected by analyzing sample of drilling sediment, fluid, and cuttings. And because of that, you are among the focal person, which your interpretations of oil and gas composition might help in explaining fluid movement within a reservoir. Alright then, because of these top 3 points, we designed this course for you guys to actually explore basic geochemical technique used to evaluate new prospect and improve your basic understanding on the processes that control petroleum quality in reservoir rock and the bulk molecular and isotopic tools that facilitate that understanding. So at the end of this course, I'm really sure that you will be able to describe on how geochemistry can reduce the risk associated with petroleum explorations, how to predict oil quality from inexpensive wellbore measurement, how to define reservoir compartments and deconvolute Cumming-Leak productions, and how to assess completion problem. Alright, so as a petroleum geochemist, we are geologists that specialize in geochemistry. So the prospect of petrogeology is actually covering the explorations, development and production. Alright, we go to the specific task as if you are working as an exploration geochemist. So to be specific, petroleum geochemistry knowledge and application will improve exploration efficiency by accounting for many of the variables that control the volumes of crude oil and natural gas available in an entrapment. So the variables here includes first, source rock distribution. So the variables here include the source rock distribution, richness, quality and thermal maturity. And the second one is timing of generation, migration, accumulation relative to trap information. So to solve the problems that occur due to these variables, we need to integrate the knowledge from other disciplines such as seismic and reservoir characterization. So as a petroleum geochemist in exploration team, your task will be first, characterizing charge reef, where you need to generate oil correlation or oil source correlation. Second, you need to calibrate the 3D thermal and fluid flow modeling. And third one, you need to determine the origin of light oil and condensate. And part of that, you need to assess the reservoir alteration. Alright, first, as a geochemist in exploration team, you need to characterize the charge reef. What is charge reef here meant for? So it is actually petroleum quantity and quality. So why a geochemist need to do this? Simple, because it serves as an early decision-making tools of petroleum system evaluation that is associated with variations of element and processes. It also involves multiple of approaches that could help and lead a company for first, not to buy seismic data in an advanced overcooked post-mature basin when you are looking for oil, because if your company is looking for a gas pool, then it's fine, because post-mature of oil window in the mature interval for a gas is the mature interval for a gas window. So you will learn this later on. And second point is not to evaluate reservoir or map traps in an area that cannot possibly be charged by or with hydrocarbon, meaning that you are the one who will make a decision in your exploration team. So basically there are three must known issues, okay, that a petroleum geochemist in exploration team has to resolve. The first one, has the trap received economic quantities of petroleum? Meaning that you need to know the volume of accumulation hydrocarbon in an entrapment. Second, what type of hydrocarbon are likely to be present? Either it's oil or gas or both or mixture, and in what relative proportions. So this actually will help development and production team to propose which drilling tools need to use to the drill engineer. And the last one is, what are the oil and gas properties? The properties here meant for viscosity, gravity, sulfur content, and waxiness. So this actually will help in development of this actually will help development and production team to propose which drilling tools need to be used by the driller or by the drill engineer. Okay, moving on. So to evaluate the first issues on whether a trap has economic value or not, you need to know in which category is your petroleum system will be. So basically we have 3 categories of petroleum system. The first one is non-petroleum system. So to classify a petroleum system as a non-petroleum system, there must be a petroleum charge exists nearby, and there must be a known hydrocarbon source rock in the basin. So if you have both of these characteristics, you can characterize your charge or prospect as low, moderate in risk to be drilled. Okay. Secondly, we have a speculative petroleum system, in which if you find that your petroleum charge supported by prolific and matured source rock nearby, but has no economic significant field exists in the basin as analog. So this is the speculative petroleum system. So for this category of petroleum system, you can classify your charge as moderate, high in risk. Alright, the third category of petroleum system is hypothesized petroleum system. So the characteristic of, if you name your petroleum system as hypothesized, is if petroleum charge is hypothesized, or you just assuming that only based on analog in the near basin. So with regards to this, your charge risk will be classified as high, moderate risk to be drilled. Alright, next, there are techniques or methods that ultimately you will use in the industry to evaluate the petroleum charge risk. The first is by generating the oil or oil source correlations. How to do this? Simple. To do the correlation, you need to have the following technique. First, you need to construct a diagram and map in which to obtain an empirical view of what has been discovered to date. In the map, they must contain first field size distributions of oil, condensate, and gas reserve for each petroleum system in the basin. Second, you need to have source of hydrocarbon of any available nearby seeps, shoals, or oil from non-commercial fields. And last one, you need to have a relations of basin history and source reservoir stratigraphy between the basin nearby and produced basin. For the second technique, you will use to generate the correlation by using oil biomarkers. Okay, what is biomarkers? It's actually fossil. Okay, fossil molecular or compound found in oil or soil, sediment, rock extract that actually indicates the origin and source of petroleum. So this is used actually to complete the source rock evaluations and maturity assessment. So by using this technique, you can make an early estimates of oil quality and quantity and the GOR for exploration target. GOR stands for gas oil ratio. Alright, what is the use of oil biomarker? Simple, we have 4 main usage of the oil biomarker. The first one is by using oil biomarker, it is useful or specifically is useful to assess the relative amount of oil prune versus gas prune organic matter in the source corrosion. Second, we can determine the age and lithology as well as the environment of depositions of the source rock, whether the oil and gas are coming from the carbonates or shale or coal. And for the environment of deposition, it's whether the oil originated from marine or lacustrine or